Okay, we are looking at problem number 14 from section 1.3 homework. For this one, we're asked to find the limit. The first thing I always do when asked to evaluate a limit is I just test to see if direct substitution is possible. And I encourage you to do that first, because if direct substitution is possible, no matter how complex the expression, if you can directly substitute, it'll save you a lot of time. So I go ahead and just directly substitute x into the expression. And then I simplify. And what I end up with is 4 minus 4, which is 0, and then 10 minus 10, which is 0. And so this is that indeterminate form. You might be thinking, okay, before I know of something called L'Hopital's rule, and I want to use that here. We have not covered L'Hopital's rule, and in fact, L'Hopital's rule's proof depends on the stuff that we're developing right now. So we can't proceed using L'Hopital's rule. If you do have that prior calc stuff, that prior calc experience, and you're in a class of L'Hopital's rule, that's great, you can do that. But in this class where we're developed so far, we cannot use L'Hopital's rule. So just be careful that you don't feel tempted to use that. And if you are going to go on to Calc 2, if you are new, that's just something you can look forward to. Okay, so what I'm going to do next is I'm going to attempt to write a numerator. So here I'm looking at the limit as x approaches 10 of the square root of x plus 6 minus 4 over x minus 10. And then I'm going to multiply numerator and denominator by a well-chosen 1. And because if we multiply something by 1, we're just changing the way that it looks, we're not changing its value. So in this case, I'm going to use the complex conjugate, which if you're not sure what the complex conjugate is, you'll want to either email me or review some college algebra, because that's where it's covered. So I'm going to multiply by the complex conjugate of the numerator. And to keep consistency, I need to multiply by the same expression in the denominator. So I'm just multiplying it by 1. I am making a slight assumption here. I'm making the assumption that x does not equal, well, in this case, x can be 10, that doesn't matter. So we don't have to make any assumptions. So when I do that, and again, I'm not going to kind of go in depth with the foiling and how to get that simplify using that complex conjugate. If that's where you're getting stuck, is this line that I go to next, just stop the video, send me an email, or reference an algebra textbook. Okay, so then here at 6, we have the square root of x plus 6 times the square root of x plus 6, we get x plus 6, and then minus 4. And notice again those two inner terms, because we chose specifically the complex conjugate of the numerator, those two middle terms are going to cancel. So we're not concerned with those. And then I have this x minus 10, and leave it factored in the denominator, the square root of x plus 6 plus 4. Okay. And from there, now I'm looking at the limit as x goes to 10, and I'm going to combine some like terms. This should be a minus, that's negative 4 times positive 4, we get a minus 16 here. So then I have an x minus 10 when I combine the like terms in the numerator, and an x minus 10 in the denominator as a factor. So we talked about in the last example, we looked at, if they agree at all but one point, and here, as long as x does not equal 10, we can cancel out the value, the factors x minus 10, x minus 10, and we can say that this expression is going to agree with the expression 1 over the quantity square root of x plus 6 plus 4, and then this becomes the limit as x goes to 10, And again, that's because we're saying x doesn't equal 10. Now we found an equivalent expression that agrees at all but one point, and that point being 10. But this new that we have is defined at 10, so now we can directly substitute in 10 for x. And so notice I've dropped my limit notation. Once you apply the direct substitution, you can drop that limit notation. So then I get 1 over the sum of 4 and 4, which gives me 1/8. So the limit of this expression as x approaches 10 becomes 1/8.